Hi folks, this is tutorial number 2 in this playlist which deals with uh, kinematics simulation in the 3D experience. Now, I'll refer to this thing as a block accelerating down a track, as you can see here. And we're assuming that the block has an acceleration of 2 inches per second squared. From elementary kinematics, if you integrate the acceleration, you're going to get the velocity, assuming the initial velocity is 0, 2t. And if you integrate this thing again, you get the position along the length of the track. So this is the problem that I'm going to be modeling for you, and I will use the law excitation. In other words, somehow I will tell the software that the acceleration is 2 inches per second squared, but I can't do that directly. So instead, I'm going to say the position along the track as a function of time is t squared. Okay. Now, keep in mind that uh, the, really in reality in front of this t squared there is a 1, but the unit of that 1 is inch per second squared, so that after I multiply by time squared I get inch. So you just have to see that. Now, because the length of the track, I'm making it to be 21 inches. If you set S equal to 20 inches, you're going to get the T. So after 4.47, this block will reach the end of the line. And I'm going to do that with law excitation, because there are other ways of doing it too, which those are going to be done later on as tutorial 2.1 and 2.2 when I use these other options. Okay. Now, let me remind you that this is the chapter 2 of the textbook that you see here. However, I have modified the basically the interface that you see here, because I'm using release 2024x of the 3D experience. Okay. All right, let's go ahead and do that. So we start with the product. So assembly, and right click, insert in this thing the track. I'll do the track first. So here is the 3D part, and I'm going to call this thing the track. Properties, I'm going to call this thing track. Okay, and call it track. This is so that I can find them easily if needed, right there, and I'm going to make it. So double click on that 3D shape on that vertical plane. I will sketch. Let's go to the part design first of all. Double click on this. Well, if it doesn't take me directly, so I'm going to go to part design. Okay, so on that vertical plane right there, we'll sketch. The lateral dimension of this track doesn't matter, so I'm going to make this thing like so, just to be on the I'll make this thing 1, and although it doesn't matter, I'll make this thing 0.5. Okay, exit, and then pad it by 21 inches. Okay, so this is going to be my track, and then I'll go all the way to the top, insert, put the cursor there, right click, insert, another 3D part, and I'm going to call this thing the block. Right click, properties, call this thing the block, and the reference is the block. Okay, I'll make it. So double click on this. So you're going to part design. Anywhere you want, for example, on that horizontal plane, I will sketch. something that looks like this, one by one. So let me give some dimensions here. This is 1, and this is also going to be 1, just for bookkeeping purposes. Exit and pad it up by 1 inch. So there's my block. Okay, all the way to the top. Now let's put them in the right spots. So we can use the engineering connection, but I don't want to create a connection to put this thing on that track. So instead I use the snap. So if you go to the manipulation under snap, I snap this point to that point. So no connections are created, it's just moved there. The snap is very useful for things like this. Now, we know that this is going to be a prismatic joint, so you go to the under the connection, under engineering connection, you select a prismatic joint, and there are different ways of doing let me get through this. The different ways of doing the um, prismatic joint. So I use a template. For example, I use 2 lines coincident, this line and that line, 2 planes coincident. For example, or I can use coincidence between this plane and that plane, or the bottom plane of this and the top plane, or you can use contact. So I'm going to use this, okay? So this is coincidence between this edge, see that's the edge, and that edge, okay? And plane is going to be coincidence between this plane and that plane, okay? And offset, because I want to be able to control this thing later on by measuring the distance from that plane to that plane. So that's going to be right here. So this plane to that plane, which is going to be this, okay? Uh, good. And we say, okay. I don't care about the contact and interference. So I say, no, don't worry about it. Okay, good, good. So notice that the connections have been created here. Let me update this thing. Oh, by the way, I forgot to fix this. So let me go ahead here to the, once again, to connection, engineering connection, fix the track, okay? Okay, and now update. So this is all taken care of. Very good. We now go to our mechanical system design. Okay. So here is mechanism representation. Let's go ahead and create one. This second tab already, these are checked, so I don't have to do that. I'll just say OK. Good. Now this arrow simply means that the block will travel in this direction. Now I don't want that, so what you can do, you can select this, put the cursor there, and flip the direction so that it travels in this direction later on. There we are. Okay, flip the direction. Notice that if you want to change it again, you select this and you flip it. Now I don't want to do that. I want it to go in this direction. Very good. Okay, now let me click on the mechanism manager. Notice that there is a green check mark here. There is a prismatic joint that's length driven, and there is a block that is actually fixed. Okay, good. And then we say okay. This is just to show you that I have that green check mark and I can move. Now, let's try it first. Before we put any physics into it, etc., I'm going to click on this mechanism player right there. See that? Notice that you can move, we can increase that by positive values. And if I move this sliding bar to the right, because I flipped the direction of the arrow, it'll go in this direction. Check it out. Yep. Reset. If I move it to the left, it'll go in the opposite direction. Reset. So it is doing what it's supposed to. Okay, I haven't put any essentially physics into the problem yet. Okay, now what I'm going to do is now we'll switch to mechanical systems experience. We already have a mechanism, so we don't have to do that. And we're going to do the scenario ourselves. We say okay. And this is the name, that's fine. Notice that there's a essentially a scenario has been created here. Okay, and first thing I'm going to put that physics laws of physics into it. Now remember, I want the position to be t squared. Okay, so I go here, you click on law excitation. The support is that command that I gave it. Remember, I made it length driven by creating that offset there. So you click this, and you click on f of x. If you want to put a function here, and I know what it is, just look at what it is. It's 1 inch per second squared times time squared. Okay, so we have 1 inch underscore s2, that means 1 inch per second squared, times time. Here is select this time here on the left, on the right side, and select this, either left double click on it so that it puts it there automatically for you, or start typing these things. Okay, notice that when you left double click, it puts it up there. Don't just select it, because it's not going to put it up there anyway. And then to make units consistent, we said star 2. So notice that the left hand side is inches, the right hand side is inch divided by second squared times time squared, the unit is inches. And if there is a typo here, you will get the syntax error, etc., which is fine. Now we say okay. So now we have created an excitation here, and now we're going to do a kinematic scenario right there. Kinematic scenario. This book does not use dynamic scenarios, but later on, after I do all these chapters, I will include some stuff on dynamics. Now here's the excitation that I selected. I could have given it a name, and you move the arrow, using the arrow, move it to the right. Select the second tab right there, and I'm going to do it over a, let's say, 4.47 seconds, and time increment of time steps of 0.1. Now, I also want to create a probe, because I want to be able to plot the velocity and acceleration and the position of this point. So we say, okay, I did not create the probe. I say, okay, but there is a probe here. There is a probe. See that probe? Position and acceleration, speed and acceleration. So let's select this corner point. And so this is the point that we're going to be able to plot stuff about. So you have to create a probe here, and you have to include it, because I did not include it in my scenario. So left double click on the scenario there, left double click on this, and on the probe, oh, it was already picked, okay, because I didn't have to include it, because once you select once you create a probe, it puts on the right hand side. Fine, no problem. Now, let's update and see whether these will go away. Okay, this will not go away until we actually run it. Okay, so what do we do here? So you go here all the way to the right. See that? All the way to the right. Okay. And just say compute and generate results. You'll do it. Notice that it starts slowly and it builds up velocity. It's supposed to, because it's a constant acceleration. And when it reaches the end, it stops. Okay, so it did create our cartoon, but there's physics behind this. Okay, so if you click on this play animation, you can play it right here. See that? You can play it. Let me move this thing on the right side. Slowly builds up speed, and it reaches the end around 4.47 seconds. Okay, so you can also use this arrow to make it go forward and backward in one direction, etc. This is going forward, it jumps to the other side. Okay, if you click on this again, it goes forward and backward. Yeah, but that part of it is, of course, is making the cartoon. So this is fine. We're fine. So let's stop this thing. Actually, let's send it all the way to the end. Oops, there, and we close that. Now, I want to create the path of this. Obviously, this is not rocket science. The path of this is a straight line. So how do we do that? You go to geometric trace, see that? It says, where's the point that I want to get its path? So let me, for example, select that, that back point. And then there's going to be 448 locations selected for it. That's fine. Okay, good, there we are. See that? This is the path. Now to put it in the part, so what I can do in the assembly, I can right click, copy, and go back to my kinematic simulation here. Let me see if I can put it here. Right click paste. Well, let's go put it back there. Right click paste. There we are. Okay. So if you go to kinematic simulation, you can see that if you animate it, okay, there. If you animate it, it'll just follow that that corner point follows that path. This is obvious. It's not rocket science. The other thing is that suppose we want to go back here. Suppose we want to find the swept volume. So you click on the swept volume. Okay, so what we want element to sweep is going to be that element, and yeah, sweep all moving part. Fine, there we are. Basically, this is the volume that's going to be swept. That block sweeps this thing. Again, you can copy this thing and put it there if you want, and there may be other ways that you can insert it there. So you save it. Probably you can insert an existing 3D shape, but that's okay. I'll leave it the way it is. But let's go back here. Suppose I want to plot some stuff. So I go here to the back to the results here. Click on the view simulation results. Just give it a minute. Deselect everything. So I'm going to select the first of all the velocity or x velocity. This direction is x. X acceleration. Incidentally, that's going to be a constant. This is the position. This is the velocity, and this is the acceleration. Where is that? Magnitude of the x acceleration. So acceleration is going to be constant, 2 inches per second squared. Velocity is going to be 2t, linearly varying, and position is going to be parabolic. If you click on the plot tab right there, there we are. So you can see that this is the length. This curve is the length. This this is the length. Hang in there. Let's see now. Kind of hard to get these things. Okay, here we are. The brown is the position, parabolic. You can see that right there. And the pink one is the velocity in the x component, which is the same as velocity magnitude. And this is the acceleration, which is 2 inches per second squared. Of course, you can get the values if you want to export it to an Excel spreadsheet and do other things with it. You can do that. So back to the plot, okay. And if you're done, just close it. And that takes care of this tutorial from essentially chapter 2. Tutorial 2 from chapter 2. As I said, later on, I will do 2.1, 2.2, 2.3, where I use different type of excitation. Right now, I use law excitation. Later on, I'm going to be doing excitation based on a sketch and excitation based on it's called segmented excitation, and one which is based on design table. Good luck.